All right, welcome back. This is part 2 of our lesson on factoring. And next we're going to look at a difference of squares. And a difference of squares in general can be written as a squared minus b squared. And a difference of squares always factors into what we call conjugates. So one factor will be a plus b, and the other factor will be a minus b. And we'll see that when we do this example. So number 7 is 64r squared minus 49. So even if you didn't think about it as being a difference of squares, you could still start by just setting up two binomials. And to get 64r squared, you could factor it into 8r times 8r. And then to get negative 49, you could factor it into plus 7 and negative 7. And then you'll notice when you calculate the inside, which is 56r, plus the outside, which is negative 56r, they add to 0, and that's why we don't have a middle term. We just have a binomial, not a trinomial. So again, these two expressions are called conjugates. They're conjugates of each other. They look the same except one has a plus, one has a minus, and when you multiply conjugates, you always get a difference of squares. Okay. Let's take a look at what's next. All right. So we're going to combine multiple types of factoring. Sometimes there's one kind of factoring in a problem, but sometimes there's more than one kind of factoring in a problem. So number 8 here, we're looking at something that has 4 terms. And when you look at the first 3 terms, you might notice that that looks like a trinomial that you could factor. That looks like a perfect square trinomial. So if we factor that part, we can factor it into x plus 9 times x plus 9, or if we consolidate those together, x plus 9 quantity squared. And we still have minus 25y squared. So technically we haven't factored the expression because our expression is currently a difference, not a product. It has a minus in it, not just multiplication. So notice that we have something squared minus something squared. In fact, you could think of the last part, the 25y squared, as being 5y quantity squared. So we have something squared minus something squared. And we just talked about how that is called a difference of squares. Something squared minus something squared. And we factor a difference of squares into conjugates. So we're going to factor x plus 9 quantity squared into x plus 9 times x plus 9. We're going to factor 5y quantity squared into 5y times 5y, and then we have 1 with a plus and 1 with a minus. Okay, so that's one example of multiple types of factoring, and of course there are all other kinds of ways to combine factoring. Okay, let's look at a difference of cubes. Remember how a difference of squares was like a squared minus b squared? So a difference of cubes would be something of the form a cubed minus b cubed. And hopefully when you were in Algebra 2, you learned a formula for this. And whether you did or not, now's the time to learn it or relearn it. So a cubed minus b cubed factors into a minus b times a squared plus ab plus b squared. That's something that you're going to need to memorize. And so in a minute, I'm going to give you a kind of a mental game thing to help you remember it. Sort of a, oh, what's the word? When you have a mental trick to remember. We'll just put it that way. Apparently I need a mental trick right now to remember what I'm trying to say. So here's our example, t cubed minus 1,000. So this is a difference of cubes. T is cubed and 1,000 is 10 cubed. Okay, so we're thinking of our t as our a and our 10 as our b. So the first thing we have is a minus b. So that means the first thing we're going to have is t minus 10. That's one factor. And then the second factor has a squared. That's going to be t squared. Then we see a plus, And then we have AB, so that's going to be 10 times t. And then we have a plus, and then we have b squared, so that's going to be 10 squared, and that's 100. So that one is now factored. Now you can look at the quadratic part, the quadratic factor there, and you could try to factor that further, but it's not going to factor further. All right, so now let's look at the next one. It's called sum of cubes. So we have difference of cubes and we have sum of cubes. So sum of cubes is going to be a cubed plus b cubed. And that factors into a plus b times a squared minus ab plus b squared. So let's take a moment to compare these formulas, and this is where you're going to get your little mental trick to remind you what to do. Okay, notice that when it's minus, the first sign is minus. Notice that when it's plus, the first sign is plus. So this is the same sign as the sign you start with. S for same. Notice that in the difference of cubes you now have a plus, and in the sum of cubes you now have a minus. So this is the opposite of the sign you just wrote. So O for opposite. Now notice that the next sign in both of them is a plus. So that one is always positive no matter which formula you're doing. AP for always positive. So I like to refer to these as the SOAP formulas. SOAP stands for same, opposite, and always positive, and that's a way you can remember the signs involved in these formulas. It doesn't tell you everything about the formula, but at least it tells you which signs to use. Okay, so now let's do an example of a sum of cubes. So G is being cubed, G is our A, and then for 8, h to the 6th power, 8 is the same as 2 cubed, and h to the 6th power is the same as h squared cubed. So what we're cubing is 2h squared. So G is our A, and 2h squared is our B. So let's go ahead and factor that using the formula. So for a plus b, we're going to have g plus 2h squared. And then for a squared minus ab plus b squared, we're going to have g squared minus 2g cubed h squared plus, now we need to square our 2h squared. So that's going to be 4h to the 4th. Okay. Let's see what we have left. I think we're getting close to the end here. We have an example of grouping, and then we have a challenge problem. So, depending on who your teacher was last year, maybe you learned with grouping to break it up, 2 terms and 2 terms. It's not always 2 and 2, but it's often 2 and 2. So what we're doing in this type of factoring is we're looking at the first 2 terms and pulling out the greatest common factor. So in this case, that would be n squared. So we have n squared times p plus 3. Then we're looking at the last 2 terms, and we're pulling out the greatest common factor, and that would be negative 5. So we have minus 5 times the quantity p plus 3. So observe, we have p plus 3 as a factor of the first part of the problem, and p plus 3 as a factor of the second part of the problem. So let's factor p plus 3 out of both parts of the problem. And the other factor is going to be what remains, n squared minus 5. Okay, so we have our factors. And don't forget, sometimes there's another step of factoring. So if instead of n squared minus 5, we had n squared minus 4, that would factor further because that would be a difference of squares. So you just have to pay attention to what you have in each problem. Okay, so let's end with a challenge problem here. Factor x to the 6th power minus 1 2 different ways. So go ahead and pause and give that a try, and then you can come back and compare what you did with mine. Okay, x to the 6th minus 1 is a difference of squares. It's also a difference of cubes. So first I'm going to factor it as a difference of squares. X cubed squared minus 1 squared. So according to the difference of squares factoring formula, we're going to have 2 factors that are conjugates. So we have x cubed plus 1, and we have x cubed minus 1. Now we're not done because x cubed plus 1 is itself a sum of cubes. And x cubed minus 1 is itself a difference of squares. A difference of cubes. Okay, so let's factor the sum of cubes. X cubed plus 1, it's the same as x cubed plus 1 cubed. That would factor into, using our SOAP formula, x plus 1 times x squared minus x plus 1. And then our difference of cubes, x cubed minus 1 cubed, using our SOAP formula, factors into x minus 1 times x squared plus x plus 1. Now, suppose we take the problem and think of it as a difference of squares. So we have x squared cubed, a difference of cubes. So we have x squared cubed minus 1 cubed. So we're going to use our difference of cubes SOAP formula, and we have x squared minus 1 times x squared squared, which would be x to the 4th, plus 1 times x squared plus 1 squared. Now, that one's not done because x squared minus 1 is a sum of squares. Sorry. Oh, I must be getting tired. Not a sum of squares, a what? Correct me. A difference of squares. Difference of squares. So it factors into conjugates. X squared minus 1 factors into x plus 1 times x minus 1. And then we have this other factor here. Now, I don't know about you, but I'm seeing these answers look different. And what I'm thinking is that's telling us that x to the 4th plus x squared plus 1 actually could be factored into x squared minus x plus 1 times x squared plus x plus 1. We don't really have the skills to factor in that way, but now we see that those are equivalent. Okay, it's time for me to give you your assignment. So we're doing a potpourri of factoring problems that are handpicked just for you. And you'll notice that some of them have hearts around them. That's because there are tutorial videos available for those. And on Canvas, you'll find the links to those tutorial videos. So if you happen to get stuck on 47, 57, or 79, watch the tutorial videos. And remember, when you're done, you're going to submit your notes, work, and show that you have checked and corrected your work. And if you finish the assignment and you have no questions and you're ready to submit it anytime today, go for it. And if you need to ask questions next time before you submit it, that's fine too. Just wait till you get your questions resolved. Thanks, everybody.